Our next speaker is here with me. Let's bring him on if we can. Dan Nye. He's the Chief Strategy Officer at Graphex Group. Dan, there he is. That is a real view, isn't it?
It's beautiful. It's London right now. It's a great day in London.
Oh, man. You are definitely winning the day so far in terms of background views. I'll tell you that.
Appreciate it.
I'm cynical because I thought is it a blue screen at first, or no? It's real. It's all real. So guys, we have Dan's presentation. Let's get that up on the screen, and Dan, I will turn it over to you and let you go with it. Here we go.
Great, thank you. First of all, thank you for the introduction, Spencer. It's a real pleasure to be here. Welcome everyone to the conference, and thank you so much for the opportunity to present our business. In the next 15 minutes or so, we will seek to provide you with a brief overview of our company and its underlying technology. Firstly, please see our website for our forward-looking statement disclaimer. So an overview, we develop technology and produce products for the renewable energy sector. Specifically, we manufacture spherical graphite in production volumes and develop graphene technology. Spherical graphite is the material used to produce the graphite anodes for lithium-ion batteries, which are used both in electric vehicles and for renewable energy storage solutions. Our technology is protected by 23 spherical graphite and graphene patents. Our 2020 revenues were about $51 million US. We are EBITDA positive. We trade on both the OTCQX in the US and the Hong Kong Stock Exchange. Our symbol in the US is GRFXY, and in Hong Kong it's 6128. We currently produce about 10,000 metric tons per year of spherical graphite, or as we know it, SG. Just touching on leadership, Andres Chen is our CEO. He has been with the company since 2013 and brings 34 years of business experience. I come from a technology, investment, and strategy background. And Professor Lee Quinn is head of research and holds doctorates in both engineering and minerals processing. So our primary product is spherical graphite, which represents the majority of our revenues. We also develop graphene technology. Our byproducts include high purity graphite and micronized graphite. These byproducts are used in industrial applications such as lubricants and coatings. So to understand where our product is used, the following diagram shows our spherical graphite product in real life application. So spherical graphite is used to produce the graphite electrode or anode for lithium-ion battery cell. The graphite electrode consists of many layers of graphene produced by spherical graphite. This image shows a teardown of a typical lithium-ion cell used in an electric car. The average electric vehicle will have about 7,000 of these cells in parallel, and we estimate that each electric vehicle requires about 70 kilograms of spherical graphite, and this compares to about 60 kilograms of lithium and 20 kilograms of cobalt in a typical EV battery. So when charging, what happens is lithium ions are forced from the cathode across the separator and are trapped within layers of graphene within the anode, which is formed by spherical graphite. During discharge, the lithium ions fall back across the separator to the cathode, and this movement of lithium ions is what releases electrical energy and which powers the car. So we believe our business has a strong competitive moat. We have stable access to our input material, which is raw flake graphite. And our factory is geographically located adjacent to one of the world's largest graphite resources in Heilongjiang province in China. We have the experience, know-how, and patents, and we've been in production for many years producing spherical graphite in large commercial volumes. And importantly, we can also produce very small diameter spherical graphite down to 6 to 9 micron level. Typically, the market looks for spherical graphite in the 10 to 15 micron level. As batteries get more advanced, battery makers will look for actually smaller diameter graphite, and this is important to increase capacity and battery charging speeds. So companies essentially driven by, the fantastic growth rate of electric vehicles. So this chart shows on the green vertical bars the amount of vehicles produced across the world of any kind, so electric, ICE, hybrid. The line graph that goes across is electric vehicles and their growth compared to total vehicles in the world. So if you look back at 2019, about 2.1 million EVs were produced globally, and that compares to 96 million cars produced across the world. 2020, that actually has risen to 3 million, and this year it's expected that over 6 million EVs will be produced. Looking forward, by 2030, we would expect about a third of all vehicles to be electric, which is equivalent to about 35 million vehicles a year. So this fantastic growth rates in EVs will increase and power demand for our products. So with each electric vehicle requiring about 70 kilograms of spherical graphite, this trend should drive demand for spherical graphite fivefold by 2026. In 2020, about 240,000 tons were produced in China for spherical graphite. This is expected to rise to 1.3 million tons by 2026. And we plan to increase our capacity to participate in this growth rate. So this graph is basically a snapshot of battery metal usage, and it's 3 time frames. It's 2018 and looking forward 2023 and 2028. Spherical graphite is in red, lithium is in green, and cobalt is in yellow. But what's interesting about this graph is while all battery metals should increase in demand, so all boats will rise, what's interesting is the growth of spherical graphite for the graphite anode will increase faster. And that's also a function of battery makers trying to reduce the amount of cobalt in their battery. So lithium demand for the renewable energy sector is also a demand factor for our company, and it shows a similar picture. Batteries are used to store and supply electrical power when the wind is not blowing or the sun is not shining. So it's forecast by 2025 there will be 62 gigawatts of electrical energy storage added per year. We estimate that each megawatt of storage requires about 4 tons of spherical graphite. So we believe that this should create an incremental 248,000 tons of graphite demand by 2026. We have a couple of elements to our growth strategy. So where we are presently, where we are a volume producer and producing about 10,000 metric tons per year at our facility in China, which represents about 5% of China's output. Over the next 3 years, we're looking to move our production from 10,000 metric tons to 40,000 metric tons. Outside of China, we're looking to lever our technology using technology as a services model. So what this means, we're looking to work with companies in North America, Europe, and Africa. And our plan is to help graphite miners in these regions of the world convert the raw material, the raw graphite into spherical graphite so they can begin to participate in the battery supply chain. Longer term, we're looking to expanding downstream into anode and battery production. So using our technology as a service model in Europe, North America, and Africa, this is what we can do for potential clients. So presently, a graphite mine will be selling their products to the general market at about $600 to $750 per ton. By processing it using our technology into spherical graphites, they can achieve $3,000 US dollars a ton. By pitch coating it, they should be able to achieve $7,000 to $12,000 per ton, and we can help companies do those 2 last steps. We place a great deal of emphasis on internal research, and indeed this is a significant component of our competitive advantage. We hold 23 patents protecting both production techniques and graphene applications. With years of experience, we have deep proprietary knowledge to enhance our production yields. Our research team is led by Professor Lee Quinn, who we talked about earlier. And our research currently includes ultra-low temperature anodes and silicon carbon composite anodes. So in addition to producing spherical graphites, we also develop graphene technology. I think it's important to touch on, literally what an amazing material graphene is. Graphene is essentially a lattice of carbon atoms, one atomic layer thick. This lattice structure provides graphene with some really unique engineering properties. It's 200 times stronger than steel. Indeed, it's the strongest material known to man. It's flexible, it's thermally conductive, it's transparent, it's electrically conductive, it's 1,000,000 times thinner than a sheet of paper. And together, these unique properties solve many engineering problems. Just some examples of sectors which are seeking to use graphene technology includes biomedical, where graphene can be used for varied applications, including drug delivery and tissue scaffolding. Composite materials, which by combining carbon fiber with graphene, you improve strength, thermal, and weight properties. Consumer electronics, so you can produce mobile, flexible displays for wearable devices. In the energy sector, graphene may be used to create ultra-thin solar panels, or as a layer on the solar cell to actually generate electricity from the salt within raindrops. As a membrane, graphene can target specific gases or molecules and can be used in filter or sensor applications. So lastly, we also have an eco-design subsidiary, and this subsidiary specializes in landscape architecture for corporate campuses, urban renewals, and is developing recharge parks. So recharge parks are an interesting concept. We'll share a brief video with you, but essentially they are renewed urban spaces for recharging cars, and they're powered by renewable energy to an extent. And this allows mobile and vehicle users to recharge their machines while they unwind and relax in a stunning landscape space. Okay. Thank you so much for your attention, interest, and company, and I'll be delighted to answer any questions. Thank you.
Thanks a lot, Dan. Got a couple questions here for you. Let's just start with. Let's just start broad. You're over in London. Our last speaker and I talked about how far ahead Europe is compared to the U.S. when it comes to just EV adoption. That being said, what is the biggest headwind for EV adoption, EV growth? We can go worldwide, we can go Europe, we can go pick your market. But I'm curious what you think is just the biggest general headwind.
Yeah, Europe, by any stretch of measure, is significantly ahead of both Asia and US in adoption. And to give you some numbers behind that, so Europe now sells about 15% of every car sold is a EV. That compares to about 12% in China and about 2% in the US. So it's beginning to. So it is an important initiative in Europe, and that's the key thing, in my opinion, that kind of holds back even faster adoption is the infrastructure. So having fast chargers which are located everywhere is the single item which I think the world's got to solve. And if you have the same level of fast chargers located the same frequency as gas stations, then that would eliminate the whole issue of range anxiety. So the batteries will continue to get higher, more powerful, and charge faster, but the infrastructure needs to catch up. So we're just not quite there yet.
I'm wondering then about future generations of batteries. Will they still use graphite, like from your company?
Yeah. So there is development into something called the silicon graphite hybrid alloy. So currently, there has been research done to use silicon as the anode. And the problem using silicon as an anode is basically when you charge it up, it actually heats up and can crack, which is not really suitable in a automotive environment. So where the technology is moving to, and this may take a number of years to get there, is to use a hybrid of silicon and spherical graphite. And by combining those two materials, you should be able to have the flexibility offered by the graphites combined with the increased charging capacity of silicon, and have a silicon graphite anode. That's but in the kind of research that I've read, all batteries have a graphite element.
So just to clarify, this is also from the chat. So your production is based in China, is that right?
Yes, that's
okay.
Correct.
Okay.
So the actual processing facility is in Heilongjiang Province, China.
Okay. But I'm just wondering, so you've got the production in China, but you've got the technology as a service model elsewhere. Do those work hand in hand? I'm just one, or does one sort of?
Yeah, for sure. So if you kind of think of it, if you kind of think about what happened over the last 20 years, I mean, so lots of technology done in the West was taken into China. This is thinking kind of the other way. So using technology and skill sets built on producing spherical graphite in China, and using this to help graphite mines in the West, Africa and the West, convert their graphite into spherical graphite. So it's actually using deep-seated proprietary knowledge and deep-seated skill sets to help mines get to the next level.
Here is a question from the chat. This is a little more sciencey question. So the graphite is in the circular pattern. So where does the heat go?
The graphite in circular pattern. It's the heat is. So if you think of spherical graphite is small diameter graphite. So what?
Okay.
What basically happens is you compress this into a tight form. That forms your anode. So the heat gets distributed out of the battery anyway. Okay. So it's not as if it has to distribute heat. It's about 10 to 15 microns in diameter. So that will distribute heat out of the battery.
Got it. Let me make sure I got everything. There's a few questions from the chat. I think I covered them all. I guess last one here for you, Dan, and then we'll let you go. I'm not aware. This is also from the chat. Are there big competitors in your space? Who are your competitors?
It is relatively fragmented. So we're one of the top 10 in China, and there is prototype plants outside of China in the West.
Okay.
But there aren't any competitors producing production volume in the West yet. And we're seeking, using our technology service model, to expand from producing in China to actually help those companies get to production levels.
All right. Dan Nye is the Chief Strategy Officer at Graphex Group. Dan, enjoy that view, sir.
Thank you. Bye now.
All right. Everyone, smash a like for Dan Nye, the Graphite guy.